Okay.
Yay!
Yay!
So
Join stream.
yes, you probably see the Discord for now.
So, I guess hello everyone.
Hello,
So,
everyone.
um, Leandro here today, and me as backup. We're gonna be introducing Unity 101. Well, we're gonna show you how to make, like, I guess the basics of 2D game making using Unity. And but
Yes.
Leandro, this time Leandro's gonna do the live stream because he's the one that prepared a game for us.
Yes. First, I'll show you the game. Very quickly. There's nothing too fancy. We're gonna go through everything. Okay, so this is our game. We're making this amazing boy today, and look, there's a character you move, and you push this thing, and you see there's a door there that opens when you go through this plate here in the ground, and then you have to push the ball on the plate and exit, and that's the entire game. Yes.
Oh, Leandro, just make sure that you're recording the other people's voices, not only yours.
It should
Just to
be.
make sure. Okay.
It should be. Let me see.
Okay, it looks like
Speak.
it's
Yeah,
good.
yeah.
Hello?
There you go. Yeah,
That's
it's
good.
popping in like. See, see. Yeah.
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 Ah,
Nice.
there we go.
Yeah, it should be working. Okay, so that was the game. We were gonna make that. You can play again, and you can exit the task. Yeah, and we're gonna make that from scratch today. So for starters, I'm just gonna draw here quickly what we're gonna need. So you see, we had this thing here with a door about here, and there is Triangle Guy, our character, our amazing main character here. He has a suffering background, and he needs to escape this place. And then there is a boulder, supposed to be a boulder, and the plate is around here. And the plate opens the door. So here. Okay, the plate opens the door. So what we're gonna need? So this is all programmer art, so that's why it looks very bad. I wanted to make some sprites, and I didn't even draw. I even drew a character, but I didn't have time to actually make it on computer to put in the game, unfortunately. So next time. Okay, so things we need. So first we start with our player character. The player character needs movement. Movement. And that's about all it does. It moves around and collides with the walls around the level. Okay, so some collision. Okay, and then the boulder here needs to be pushed around, so it needs to be pushed around. And that's the core of the game. So once you're in the game jam, for example, and you decide the core of the game, you have something like this. You have a list of functionalities you need to think about. So our player moves.
Movement is usually like #1 priority in every single game.
Exactly. It will start with the
So.
movement most likely, and in this case it moves on all four axes here. So the X is this side and the Y is up. I'll show it on Unity later so you understand it better. And interacts with the boulder. The interaction with the boulder happens in this case automatically. You're gonna see just by running on the boulder you push it. And then you need to tie in that this plate here, once you walk on top of it, opens this door. So you'll see that in the game, if you remember, I could walk with the player there and their door opens, but because when I go out, the door closes, I cannot just walk there with the player, and I need to push the boulder into the tile there.
So to recap, we're gonna do movement first.
Yes.
Then we're gonna explain how colliders work, and then we're gonna show events. So like having the boulder on the door will on the cube will trigger an event which would open the door.
Yes. Yes.
Yeah.
And this is as much as you could do. Like if you had more than a programmer in your team, you could separate someone making the character move and someone making a tile like this work to doors, and have that done. Once you already like have the player moving, this core part that is the door opening is already done as well. Then you just need to do the boulder thing. And I understand better when I go through the code how you can think about these things more separate, so you can use them on different levels later. Because if you do this wrong, you're gonna end up with a code that you cannot reuse for different levels. You kind of need to like copy paste a lot and stuff like that. So we won't do that. But fortunately, Unity really helps us with these kinds of things. Okay, so any questions about the game or about what is gonna happen now? Because then we're gonna pop up Unity and start actual coding and programming. Oh, something I did here. I have some basic shape sprites on this link. You can download this. Uh, it's three sprites that I use in the game. It's like it's a square, and it's a triangle, and it's a little circle.
Mhm. You could use
Because
the sprites of your own if you
yeah,
find them.
if you feel
But
adventurous and you have something, use your own sprites definitely. Yeah.
yeah,
But if you don't have anything, you can use those. Like if you really want to follow
like
from exactly
like
what I'm doing. Yeah.
yeah.
Yeah. So that's all for now. Okay. So first, we'll pop up Unity Hub here, and you'll see I have Unity 2019 3.13 installed,
I
which is
mentioned before for the game jam, have everyone in your team choose the same version and
yes,
stick with it.
yes. Make sure you choose the same version. I'm going to run with the latest one here, just for the sake of the workshop. But if it happens, like you see here, I have other two installations because I have different projects running on different versions. It's not good to upgrade during the game development. If you set on that version and you work the entire game there, unless there is a point and your game is so big that you are like 2, 3, 4 versions behind and you want to upgrade, you can like communicate everyone and stuff. But that's not gonna
Mhm.
happen in the game gen, most likely. So just set in the version, make sure everyone installed the correct same version, and start from there. Okay, so first here, I have this, like, this is the project I already did, but I'm gonna start a new one just to show. First thing is you have this window here to create a new project. We'll choose 2D because it's a 2D game. You
Then
can name
just
you can name
title.
this whatever you want. I'm gonna name this Amazing Workshop Game, and I'm gonna save it in this 2D workshop because I already have other stuff here. This is the location of the folder, and this is the project name. It's gonna create a new folder for inside the folder you selected, so you don't need to create the folder with the name again. And then you hit create, and it's gonna do everything for you. You just have to wait a little.
Yeah, usually it takes a little while for Unity to load everything. Especially if you have a laptop or a less powerful computer, sometimes it takes a really long time. So if you have like a weaker computer, once you open it, try not to close it again.
Yeah.
Because it'll take a long time to reload every time.
Yeah, it's probably gonna take a little for me because it's like recording and
Oh, that's true.
yeah, so it's like really slow. I'm gonna close this yet. I'm gonna use it later.
Is that what tool, art tool are you using?
Oh, this is Medibank,
It
Medibank
looks
Paint
nice.
Pro.
Medibang.
Yeah, it's very
I
good. It
like
was a
it.
recommendation from a friend of mine and he draws. And he said, "Oh, use Medibank. It's very easy to do." And he has
Mhm.
like reticules and stuff you can use. It's made for like manga drawing or something, like comics and stuff.
Yeah, it
So
looks nice. I like it.
yeah, it
I
has a
might
lot of
I might
interesting
download it.
tools that can help. Yeah, take a look later. Okay, so this is what you're gonna end up with. Oh, I did it the wrong version. Hold on. It created a new one for the. You're not gonna have this problem.
Oh yeah, you could change the Unity version for your
Yeah,
individual projects
it's
right
just
there.
gonna recompile stuff. It's alright. Yeah, that was my bad. It normally have. You need to make sure you're selecting the correct version you're gonna work on. Don't do what I just did. But if you happen to do so when you create the project, just need to switch, and it's gonna recompile. It's fine.
Yeah, but if be careful if your game has a lot of progress on it. I've had occurrences where I was using like a terrain and uh, like actually yeah, like I had a bunch of my game was basically done and then I had to convert to another version and then like the terrain completely disappeared because of my update, which is not great.
Yeah,
So be careful.
it's not ideal, definitely. Yes. Okay, so you'll see this, not necessarily looking the same way. You'll probably see it by the default layout is probably this one. Yes, you'll probably see something
Yeah.
like this. Um, I use it differently, like I just showed it. I use the tall version. I don't know why it resets the resolution. Because I think it's nicer. I just do some like I take this out. I change some of the settings of one column and stuff just because I think it's better. But well, let's run default just to help everyone. So this is your
So
default screen. Let's explain a little of what you're seeing here. Okay, so this is your scene. This big thing on the center is where you construct your game. This is like different from the game, where this will be the game screen, like what the game is actually showing. The scene is where uh, you construct the game, because then here you can like move objects and you can do things. For example, if I create very quickly a cube here, it's gonna create a cube, and this cube is in the scene. You can move it around with the different tools here. These tools on the top are tools of movement or rotation or scaling if you need, and they work the same way for 2D and 3D.
hmm
Um,
in the game scene, however, like you could see the camera view.
yes, the game scene, you'll see what the camera sees. The camera is
Yeah.
the object that is actually literally captures what is going to the player. So I always think like this is a movie set. So your scene here is a movie set, and the camera is what is actually capturing what is going to the player, what the player is gonna see. So as you see here, the square here is the actual camera. So you can see, you can even it even shows a preview here if you select the camera.
If you put the cube outside of the camera field of view.
Yeah, it's not gonna show anymore. So the camera is what captures. You can have things on the outside here and make the camera move, for example. We're not gonna cover that this time. Probably only tomorrow, somewhat. But yeah, if you move the camera, it's gonna show things that are on the road space. This entire thing you see here is called the road space um, inside the scene, and it just simulates things in here, and the camera renders them to the player in more technical terms. But okay, so this is the scene. This is where you put objects, your sprites, your 3D models, and you like put them on the correct place, whatever you want to do. So you have like 3 cubes. I want to place them around like this so they look, and you can always switch to the game view to see what is happening. You also test the game in the game view. We're gonna see that later. Okay. So yeah, this is where you mainly construct your scene, and that's very important. Like for example, artists out there, you can test if your sprites or models are working just by importing them and putting them on a scene. It will see how it looks, mostly in the game. There are some configurations, but we'll go through that later too. Okay, so something else that is important is the hierarchy here. These are all the elements that are present in the scene. So you see here we have currently the scene name that's called simple scene, and
The camera.
and the main camera, which we just explained, and the cube I just put there. And you can select through here, which is very handy sometimes because normally you have like a lot of things on the scene and you have to like run around finding things. You can go here.
You could select the object on the hierarchy and then press F, I think,
Yeah,
to
you
focus
can.
on
If
it.
you click twice, it's gonna do this. It's gonna like really focus. But if you
Yeah.
if I put the cube like all the way,
It's like completely off screen. And
yeah, and then
you're
I go
confused.
here
Oh, where is it?
and I put my mouse back and I press F, it's just gonna do the same thing.
Yeah.
It's just a nice hotkey to have. Okay, so let's get rid of this. I'm gonna see. So by default, you have also the project tab here, which shows your
This is where
assets. It's your it's your entire
this is where
project in
everything is
files.
gonna be saved. Yeah.
Yes, yes. So you have, for example, a scene is a type of file. So you start with this. You have your assets package folder, a scenes folder, and inside you have the scene we just have now. and then the simple scene is the name. I'm gonna rename this to like test, and then reload, so it updates here. Yeah, so when we start, you'll see this building up when we start actually putting things in the game. But you can create new folders, so I can create like an art folder. I can create
Always good to
a script folder.
organize your things into different
Yeah,
folders.
and this is gonna be reflected in the Explorer if you go to the actual folder in your system here. Here you'll see these,
Go in
which is
assets.
all Unity made stuff, and then assets is the actual folder you see on the base here. These assets folder says assets, and then you have art scene script. You can see there's a Unity scene. This is all Unity specific extensions, etc., etc. But important thing is that you can see everything here as well. So yeah, always organize stuff. Organizing is important. Okay, so yes, and then on the side here, on the right, you have the inspector tab. The inspector tab is where you have information about the things in the scene. So when you select something on the hierarchy here, for example, the main camera, you have all the camera's details here. So for instance, a camera is an object which has a name, a tag, and a layer, things that are not important now. And it has a transform. A transform defines a position in the road, so you can see it's in the center here, 0, 0, with a minus 10z. The z
The
axis is not important for the
yeah.
2D right now. We're not gonna run around the z axis in any way, nor rotation, nor scale. We're just gonna do x and y in the position, but the x and y, you see if I move the camera around, the x there is gonna go up. So it's also easy if you want to like set some definite values here. You can always just put them there. It's also a good trick that there is a reset button, and you're gonna see using that later. But like the camera is normally placed correctly, just leave it there. And then there's actual camera component here. Oh, these things that are here for the temperature transform of the camera are called components. I'm gonna go through them later as well. But yeah, the camera are not gonna fizzle around. It's hard to explain. Just know
Yeah.
that the inspector is where the details are, and we're gonna look in the inspector a lot.
Can make a whole video just on like camera
Yes.
things.
Yeah.
So
Yeah.
yeah.
This asset store tab, you can close this. We're not gonna use the asset store for now. There's also a console tab by default here. We're gonna use it later to
Debug.
print debug text basically. And yeah, okay, so we can start. Are there any questions on the interface right now, like from what I explained? There's a lot of things. It's a little overwhelming, but
Oh, you could on a window you could if you click the window on the top left and you're let's say you like accidentally close one, you could put it back in
yeah,
here.
yeah, there
So
is like a window is where you can come back with things. So you can have the scene tab back, game tab back, inspector, and you can go around.
yeah.
Like there's a lot of things here. There's a
If you
sprite
accidentally like
editor, a
close
tile
one.
palette.
Yeah.
There's a lot of, but normally general is like these I just showed you. They're in general here, and
Yeah.
you can put them back in. You can also switch them around if you want to have like the inspector here. You can have it. You can have put it back, like on the top there, or if you really put them, you'll see it. If you can mess around if you want to, and if you always want to go back to the way it was, you just click default here. It's gonna reset. Or if you want to save what you customize, you can save the layout. But we're not gonna go through that, otherwise it's gonna take too much time. Yeah. Okay, so let's start. So like I said, we'll start with the player. So first thing I'm gonna do is change this color of the camera here because I hate it. It's this weird blue. So if you select your camera and the inspector in the hierarchy, and then you go to the inspector, there's the background here. This background in the camera component is the color that is the camera fills the screen with if there is nothing there. And I'm going to switch this to white because I like it. It's better. You can use black, white, any other color, but I don't like that it's weird blue. Normally you wouldn't have a problem with that, but in this case our scene is a little small, so there's some feeling that it's gonna happen. Let's see what else we need to set up first. Now what I'm gonna do here as well is set up the ratio. So when you're in the game tab, you have you can set the ratio of the game, like the screen ratio. You're by default on free aspect, so you like can mess around with the camera size or this like when you uh, make this literal tab bigger or smaller, it updates the ratio in the scene. But it's good practice to just set on a ratio and on work on that first. Normally you're gonna have like the screen ratio, but this time like the one project I just showed you, we'll do standalone if you have that. You probably have that by default. Pretty sure it's a default one, and it's gonna be 1024 by 768, and you see that the camera changed here. Uh, so free aspect, it's like this, and if I switch to standalone, it's like that, and it's fixed. Um, and that's good because then you everyone and make sure everyone will have that because it's very important for the view of the
Mm-hmm.
game. So always fix the
Especially
resolution. Go
especially
ahead.
if you have like borders or something, and if for example you had what was the other one, like free aspect,
Yeah.
uh, like if someone has a different size computer, maybe they'll be able to see parts of the game that another person is not supposed to see,
Yes.
and that's why it's better to use like a kind of universal fixed aspect ratio that everyone downloading the game will have. And yeah.
Yeah. Yeah. Yeah. So that's important. So that's set. We'll have the camera reflects that, like I said. The backgrounds change. So okay. So we have everything configured now. We'll start importing my little things here. So I'm in the art folder here in the project, and importing any kind of sprite is very easy because then I go to my general assets. It's those three things I just sent you. It's three PNGs. You can just select them on your Explorer, click and drag them to the Unity window, and let go, and it does the importing for you. It's that easy. It imports the assets there, so now you have three sprites. You can do that with the other sprites, so when your artist finishes the sprites, you can just do that. Something I'm gonna do here, which is important, and that's the communication you need to have with the artist, is that you set the number of pixels per unit on Unity. Well, what does that mean? I'm gonna, for example, if I click and drag this into the scene, you're gonna see it's very small, very small. Um, and that's fine. You can scale it if you want to, make it bigger to reflect that. But you see that it's losing resolution and stuff. So we don't want that happening. Normally on the game jam, you set for fixed sizes.
You
So
want crisp art.
yeah. So what are we gonna do? Deleting this is configure it. So I made this on a pixel art software, and I made it in 32 by 32. So I'm gonna tell Unity that a unit in the game, which is a square. So you see in the scene there is it's divided by squares. So you can tell it like this sprite. Uh, this you use 32 pixels of this sprite per unit of the scene of the road space. So each
So
square
each
here,
square. Oh, okay.
each square is a
Go
unit.
ahead.
So you go one in the x, two in the x. You're going here and one in the y. It goes like this. So each square represents the measure of 1 by 1 unit in the road space. So when I tell it to have 32 pixels per unit, it's gonna have the circle is gonna be precisely on the size of the square.
Okay, it's gonna have like 32 pixels per square
Exactly.
and
So you
X
see, like
and
for
Y.
example, the square here is not properly done, so it's like very small. So normally you have, especially pixel art, that you have this the size is really set in stone. It's very important to remember the ratio you have. Um,
Um,
yeah, so do that.
and the filter mode needs to be.
Yes. Normally, also with pixel art, you want to take out filters because then it just shows the raw image. So that's much better. As you see, if I apply the bilinear filter, it blurs.
It's kind of like blending the colors together,
Yeah,
and we
yeah,
don't really want that.
exactly. Okay, so there. I'm gonna delete this. I'm gonna put a triangle there. Oop, I need to do that for all of them. Yes, so do that for all of them. So 32 here, and take the filtering out.
Don't forget to apply.
Yeah, applying is important. It's if you don't apply, you're gonna like, what is happening? Okay, so now we have our triangle here in the scene. It's called triangle. It's as easy as that. You can just drag and drop, which is nice. I'm gonna call this the player. You can change the name here. So we can call it player. You can call it triangle. You can call it like amazing player, whatever you wanna call it. I'm just calling it player. And I'll reset this. Just make sure so you can click on these three dots here and reset. So everything is 0, 0, 0. It's in the center of the road. And it's very important to start from there. Okay, so you'll see here in the game screen, it's over there. Something else I'm gonna do here, for the sake of everything being white, is painting this triangle red. So sprites in Unity, you can apply a tint on top of them. They have the actual sprite colors that you already painted, but you can pass just like a brush of that color on top with whatever alpha you want, and it's gonna change. It's gonna blend in with the color of the sprite. Since this sprite is white, it's just gonna change from white to red. We can do any red here, and you see it reflects there. Boom. So you have a red triangle, which is our player.
Maybe you could explain that you could hide the camera because like it's on top of the triangle right now.
Oh yeah. You can just
So
turn off like gizmos in general, and especially the camera here. You go in this list.
there's so many things.
Yeah, there's a lot of gizmos, but mainly the camera.
Oh, there you go.
Oh no. I actually want the camera gizmo.
I think you did it. No.
It just
It's
took
right
out.
there.
It didn't take out
Oh, okay.
the thingy. Where is it? I don't quite remember.
But you could.
Oh, there you go. The gizmo here. Boom. Yeah.
Oh,
This little thing here is the icon. The icon. You turn it off. So
you could
now
also hide the object itself, like the main camera,
this
with
one with
the
the
check mark.
yeah.
If you,
So when you want to, yeah, if you want to like make things disappear, you could just check that thing over here, or also with this guy. So there's a difference here. It's important. So if this checkbox here, it's actually deactivated in the scene. So it's not gonna. If you play the scene, it's not gonna. It's like the object doesn't exist. Over here, if you do this, it just disappears from view. It's still there. So if you play, and you can see here, it's still there. It's just for the scene, so you have like a more clear view of the scene you want to see, and you can hide things you don't need to see anymore, just to work on a more clean space. Yes. Okay, so save. Control S to save the scene. Okay, so we set it. Alright, so let's start doing some coding. So first we need to walk around. First things first. So for that, we're gonna create a script. So this is our script folder. I'm gonna create a new C# script over like this. I'm gonna name this player controller. It's like one of the most famous names ever, and like you'll probably have that each game and every game you make in any engine, most likely. So it's just as easy as that. You create and you give it a name, and then it's created. So I'll change something here very quickly because I forgot to
oh,
change.
this is very important for everyone that's using Unity for the first time. Please follow what he's doing right now. So go on preferences and external script editor. Always make sure that you're in Visual Studio 2019.
Yeah.
And
yeah.
so that when you click on the script, it will like automatically open Visual Studio.
Yeah, I'll just show that.
for
But
you.
you see, you have a list here. So if you're like more of an other editor person, you can choose another IDE. So for example, I use Code most of the time. That's why it's here. But you can use any others. They won't have like all the easy of use that Visual Studio gives. Code does have it, but if you use like a Notepad++ or just like Emacs or something more archaic like that, you won't have like autocomplete and all the help that Visual Studio provides.
Yeah.
So we're gonna click twice there, and it's gonna open the script for us and Visual Studio, which may take a while. there. Um, so what you see here is the basic of a Unity script. So it's object-oriented programming, so you have a class. And you have the name you set there. When you create the script, that's the name it's going to be here. And this is very important. If you ever change the name of a script, you need to change this name as well. Because it's going to know that it's the correct class.
Yeah, they have to match all the time,
Yeah.
basically.
And if you know what it means, this is a inheritance thing. Inherits from mono behavior, which means it's a Unity object. So Unity knows that it can run these two functions here, methods actually. So, okay, so you guys know that a game runs on a loop, right? I'm gonna draw this. This is something, it's a concept that is very important to know. How do I have a, do I have a eraser somewhere? Here. No, this is small. Let's go very big. Nice. Okay, so a game runs on a loop. So on Unity, you have a scene. And once you play that scene, it creates everything first, creates objects. So this is number 1. So creates objects, objects. I hate writing like this. It's weird. And then on second, it's gonna start arbitrarily. You don't really know normally what's the order here, but arbitrarily every object that is created is gonna run the start method. Basically, but there's
like
other things that can go before or after, and I can show them later. But mainly, that's what you're gonna have for like a smaller game.
The start is just like everything that's like initialized like the instant you play the game.
Yes, yes, and it runs only once. That's very important. It runs only once. It's the start. It's gonna set everything it needs to set. If you need to initialize any variables and stuff, and then here you have the game loop starting. Once you go through the start and all the initializations, it's gonna start running the updates. Update. And this runs every frame. It's once per frame. And times per frame. Please fit. There you go. And then it's just gonna loop this through. It's gonna update, 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 and until you finish the game. Until it and by the end it's like end scene, which it unloads everything from memory, etc., etc.
I added a link in the resources that you could click. It's basically a in-depth documentation of the Unity loop.
Yeah.
So if you really want to go like and look at every single function and how they are involved in the game logic, well, in the loop, I guess. This is a good documentation.
Yeah. This is very
Explain
advanced
everything.
stuff. So as you can see, if you open it, you will see the start here, like I was saying, very much in the beginning. You have awake sometimes you can use. That is like very, very, very like first thing that happens. Also runs once, but we're not gonna cover awake today. We don't need it. We're just gonna use start, which is the most common one. And then you see like after a lot of stuff, the physics
Well, there's
simulation, fixed update, which runs in the runs with the physics, which is good to know. When you have physics in your game, you'll probably use fixed update more than update. But although we're gonna use the rigid bodies here to do some of the game, we won't necessarily need to use the fixed update one. And then update actually runs the logic, so it goes after the physics is simulated and after the input's done, which is very important too. You'll see. And then updates here, and then the rest is not important.
Decommissioning is the end.
Yeah, this is where
everything gets destroyed.
Exactly. It's
From
creating the
memory.
application. You can have like these are all methods you can call on script. So if you feel adventures like an application quit, you like execute something you want, like it saves something you want to save in the for the game and stuff. If you have like save on quit kind of things, you will want to use this, for example. Or if this like object is destroyed, do this, things like that. Yeah, but like I said, this is more advanced things. We're not gonna cover them today. Yeah, so but this is the basic thing. It creates the objects, and it starts executes the start method, and then executes update every frame until the scene ends. And when you load the next scene, it's just gonna stop everything. Is that clear? Should be.
Yes. Well,
Yeah.
I hope so.
Yeah. Okay, so as you see here, there's a start, and it says here, start is called before the first frame update. And then updates called once per frame. Boom. That's all we need for now. So let's start coding. For real. Okay, so we have our player here. We want it to move in the X and Y axis. So like I said, it's gonna move to the right, to the right,
To
up,
the top.
down, left. You know, it moves all four directions. So first we need to make sure that's possible. So I'll go through first, just having, for example here, let's make him go to the right. So if I go, so you can access any component inside an object by the script. So if you just type transform here, it's gonna know you're trying to find this transform that
Which
is
is like the
in the player.
positions, rotation,
Yeah,
scales.
and like this is very visual here, which is good. So every time you access a component, you have these values here. So I can go transform dot position, and it accesses those, and it's very handy because then you can find X, Y, Z, and do and change things. It's very cool. But what we're gonna do is do a translate. A translate basically moves the transform along a direction and a distance. But we're gonna give it a direction, and it's gonna update this X here, or well, it takes a vector, so it's gonna update all the position according to the vector put. It's just gonna like do a sum. It's gonna sum, like, so if our vector is like 1 0 0, it's gonna add 1 and then add and then add 1 and then add 1. So it's gonna move like that.
It's gonna add one to the X coordinate every.
Yes,
frame.
since I'm putting on the update, it's gonna update every frame. So my translate here is gonna be a vector 3 dot right, which is 1 0 0, like this.
It's just telling it right now to translate in the
Yes,
right direction.
exactly. So it should something. Well, let's show this. I'm gonna show this in the scene. So you're gonna see it's the X here is gonna go 1 2 3. It should go. No, it didn't. Okay. Important, very important. It's a common mistake. You need to put the script in the object.
Yes.
It's something I do all the time because I'm used to creating them like directly here. But yeah, you can get to something when I script and click and drag it to the object you want it to be in, and then it's gonna automatically know that this object executes this script. So don't forget that. Alternatively, you can create the script directly here, so you can go new script and call it new script, and then create an add. It's gonna do that for you as well. Okay, now that should work. Yes.
Oh, I went really fast.
Yeah, so since we're just adding one every frame, it's gonna go insanely fast.
But you can see on the X, like
Huh?
you see it increasing.
Yeah, let me leave it running. Yeah, see, it's increasing like 1 by frame, so that's about.
Well, it's 60 frames per second.
Yeah, you can go 60 a second. It's a lot. We don't want that. Yeah, so Unity makes handling this very easy because we can multiply this by the time dot delta time. And what is time dot delta time? Time dot delta time, you can search on the the Unity documentation as well. Is basically the offset of the time between the frames. So what it's gonna do is that it's gonna separate this distance you're walking. You want it to walk in a second. It's gonna separate that distance in small bits that is gonna walk every frame.
Is it, I have a question. Is it, so right now it's updating every, like, 60 times per second? Well, 60 frames per second?
I don't think it's fixed.
well, there's time.time, which I think is fixed, but is it like basically updating it every 60 frames as opposed to 60 times?
Yeah, what it does is that this delta time is a value that is so small. Let me show you here. The delta time. The completion time in seconds since the last frame. So it's that little interval you have between a frame and the next.
Okay. Yeah, that's. I think that's. It kind of explains what I was
Yeah.
talking about.
Yeah.
Alright.
Because then it's a very very small value. So since it's less than 1, it's gonna put your vector in a fraction of itself. So it's gonna be a fraction of itself, and you can move just that little bit every frame, and that assures that you are constantly independently of the computer you are in. It's gonna always walk that bit every frame, so it's consistent.
Yeah.
Yeah. So it's a good thing to use when you're having movements like that, especially when you're translating. That's very good to do.
Yeah.
So I'll save this. You'll see that it's gonna do things smoothly now. Should do. There you go. So it's moving very slowly, but it's moving. You see that it's much smoother is because it gets that 1 for the x and it separates in very very tiny fractions of 1 and applies that every frame. And then if you get this code and execute any other computer, it's gonna behave pretty close to the same way, and that's the important part. Independent of the frame rate you have. Okay, so our character moves to the right. Nice. That's first step here. So what we want to do, we wanted to actually move once we press a button, right? So I'll show you this little window here. You can go edit and go to I think it's project settings, yes, and then you have an input manager. So our input manager is where you configure our global inputs. You can do that manually in the code, but here it's easier to set up certain things because then your whole game will know these values, your whole project, and then you don't have to make sure like hard code the input anywhere. And then like if you have a lot of programmers, they start hard coding their own inputs, and just gets messy. So by default you have all these defined. We're not gonna use all this. We're gonna mainly use horizontal and vertical here because they all, as you can see, it's already like left and right, and these are the arrow keys, or A and D. So this is very handy because you will capture this value once these buttons are pressed and handle them as necessary. And then it captures the value for at the same time for both the arrows and the A and D, so you can have like multiple controls or things like that. Yeah. Okay, so first we want to move to the right, so it's the right arrow, which is the horizontal axis. I'll show you on the code right now how to get that. Yeah, let's do that. Okay, so you do an if. I'm assuming everyone has like a very basic understanding of coding here. I'm not gonna explain what an if is. So if
it's quite self-explanatory.
yeah, so if we have our get button is what I want. So get button down. So what is get button down? Is when it's pressed on the frame it's pressed on. It's not like if you're holding the button. It's like when I press the button, that frame it's the button down. And that's what we want, because otherwise if we use get button, it's gonna return true every frame it's still being pressed. So it's just weird.
This one button down just like checks it once, like
Yeah.
the moment it's pressed.
Yeah. Actually, I'll go get key down just to show this concept because it's easier. So I'll go key code dot right arrow because this is easier, and then you need to put the transform inside. Just make sure that only if you press the button, it's gonna move. Let's see if this is gonna work. Save. Don't forget to save your script. And then when you return it, it recompiles. If it says there is a change, you can see here that it changed the code over in the right here. There you go. So in the current code, it's just in the frame I pressed, so it's gonna go. I need to keep pushing the button.
Are you like clicking right now?
Yes, I'm clicking the right
Okay.
arrow because it's just on the button once I press it. You see, if you hard code that, you need to make sure like you know when it's being pressed. You need to maintain control. What the input manager does is make things a lot easier because then I define the horizontal axis. I can just get axis here, axis raw. Well, we can use axis in this case, and then we call horizontal, and tell it if it's greater than 0, which means I'm pressing the button right, because if it's less than 0, you're pressing to the left, because it's a negative value. So if I'm pressing right, this value here is gonna be greater than 0, and this is gonna evaluate to true, and then it's gonna execute this code. And just make sure like every time it's greater than 0. So if I keep pushing, it's gonna keep being true because I'm still pressing the button. And then I don't need to keep track if I let go of the button or if I'm still pushing it. It just works. See, it stops. And I push, stop, push, stop. And it works. You know, somewhat. Yeah. Yeah, so this is the basic here. So this moves to the right. Okay. Similarly, if we do the
You
horizontal.
could copy everything and
Yeah.
instead of vector 3 right, it'll be vector 3 left. But this time it will be smaller than 0.
Yeah. Less than. And then this means that this vector here is -1. And I saved it here. Yeah. Then you're gonna see I'm pressing right and stop and goes, and I press left, it goes the other way. Okay. But yeah, this is pretty slow. We don't want to do that. So what I'm gonna do here is create a speed value, private float speed, which I'm gonna put like 5.
Float is like
Is
well, there's like different types for like variables. There's
yeah.
like integer, which is
This could be an int, which is an
just
integer.
like
Just
1, 2, 3, 4, 5.
yes.
And then there's doubles, which
Just
is
whole
like
numbers.
maybe like 5.00.
Yeah, float is exactly, it's like a broken number. Let's go 5.
Yeah, so
you
like
can use
5
point something. Yeah. And then I'm gonna multiply all this by the speed here. And save. And then it's probably gonna move a little faster. There you go. See? It's a lot faster. And then we can go a mile or a kilometer more. I don't know how to say this. And we're gonna make this show over in the inspector here, because we can make things show under the component of the script. So we can change them here instead of the code. And it's easier to mess with these kinds of numbers, because for example like a speed or like a gravity, if you have a gravity in your game, if you go back to the code and change the value, come back, it's very hard to see. But if we expose the value to be here in the inspector, we can change it before playing, and after we press play we can also change it and test the value to see if what feels better. So
it's just easier to have it like accessible in the editor. Basically.
Exactly. And for that, and like we can either make this public, but if you make this public, if you know like object-oriented programming, anything that has access to the script will be able to alter that value. Even other scripts. It's not very safe. Like in general, it's not a good practice to do, unless you really want that to happen. So it's easier to do a private variable and call the serialized field under inside the what are these called again?
Brackets.
Brackets, yes. Yes. Brackets. You type serialized field, and that tells the Unity editor that you are exposing the value to it. So once it compiles here, you see the speed value here. It even makes sure it is like a uppercase. It's very beautiful. So you see that once I play, it's on a 5, so it moves like this. I can change it to 10. It's gonna move a lot faster. I can even increase it to like, I don't know, 50, and then it's just crazy. And then if you change these values, any value here really, while you're playing, this is all it's all like a test change. Unity doesn't save those, so when you press to stop playing, it's gonna go back to where it was. So normally what you do is press play, decide which value you want. So like a 7. Yeah.
It's good for playtesting.
Yeah, and then okay, 7 is good, so I'll take note of that. So 7 is the value, and then you unplay, and then you change that to 7 permanently. Over here. And then once you expose these values, it doesn't matter what you typed here, even if it's saying 5 in the code. It's not matter. It's gonna take into account the value that is in the editor here. And that's important.
By the way, the comments you did, like 100 and minus 100, will actually be 1 times the speed that you chose. So if, for example, it's 5, would be 500.
Yeah, exactly. So this is now times the speed. I just put this here to like illustrate the vector.
Yeah.
I'll just take this up for now. Yeah, but that will be the case. It will be 500 times the delta time, so it fractions that vector in a lot of
depending on the frame rate.
Exactly. Yeah, so okay, so that's 6 p.m. already. God. Alright, so let's make this go up and down right now. So it's a similar, well, it's pretty much the same code. You just copy this twice, and then you change the horizontal to vertical. Like I said, it defines the vertical as well. And if it's greater than 0, then you're going up. You can see here. If you want to test this, you can always go to the scene and move it up, and you'll see that the y value here is changing. So if it's going positive up, y is positive when you're going up. So when your vertical axis is greater than 0, you're pressing the up button, you should make it go up. So yeah, the vertical, you define up as being the positive and down as being the negative. You can see that here again. I can show this again to you just to make sure you understand. Here, up is the positive and down is the negative. And then this is only important for this check.
The vector 3 needs to be up and down.
Yeah. And then we change these to up and down. And
you could do also minus up if you're feeling frisky.
Yeah, that's true. But since it defines this is like more easy. It's easier to read, I guess. So let's just do this. And then you're gonna see that it's gonna go all around. And then since we did this ifs not nested, they are all checked separately. All of them once.
So if you have 2 buttons at the same time, it'll
yeah, it's gonna go diagonal. It can go like this.
Maybe that's what you want for the game.
Yes.
Or maybe you want if you want it to go like really only up, down, left, right, and no diagonal movement, you're gonna have to like
yeah, which is what I did for my game. I can show the code later. It's just like what happens there differently is that I call an else if here instead, and I nest these together, so only one of them is gonna execute at once.
It only checks one if statement.
Oops.
To see if it's true.
True. Exactly. So it's gonna first check this guy. It executes from top to bottom like you guys would normally expect. So it checks for the right first, and this is priority to the horizontal. So if you're pushing right or left together with up or down, it's gonna give priority to the right or left. You're gonna move right or left. And if we're pressing right and left together, it's gonna give priority to the right, unless there's like a shady area there where it doesn't really know where it's going. So if you nest these together, you're gonna see it's not gonna go up or down. It's going just the direction I'm pressing. There's a little lag, and we're gonna take care of that as well.
Oh, I don't see any lag.
There's a little lag on the input because it
Okay.
starts checking on the update. Yeah, and that happens because we're getting access here. Because what happens when you get access normally is that it assumes that your axis is like a analog stick from a controller.
Oh, okay.
So it has the gray area in between. It moves out. There is like an acceleration to the from 0 to 1. If you get the raw axis, it's just gonna be like -1, 0, and 1. It explains here with noise moving filtering applied, and then it should now not have any lag, because once you press, it's directly 1. Boom, no lag.
It's either 1 or 0.
Yeah. Yeah, that's what we wanted. Okay, cool, awesome. Was that okay to follow right now? Is
Yep.
that clear? Any questions? Okay. Okay, so that's movement. This is all we need for movement. We move around. Perfect. So what I'm gonna do here is make all this into one method, just so we make the code a little cleaner. I'm gonna call this method like movement. And then I'm gonna copy all this inside.
This is just to like organize your
Yeah.
code.
Yeah. And I
Because
call
if you have everything in update, and you're working with other people, it's just kind of like
yeah, it's gonna
hectic
be like
if
a
everything-
big because this
Yeah.
helps because I have a nice name here that really shows all this is movement, and then you can you can even put a comment here like this is movement, or like something more meaningful. And then a person that's gonna look at your code later, it's like, oh, it's calling movement. Oh, this is the movement. Oh, this is the movement. Nice. Boom, and then it keeps the update clean because the update is not gonna have. It's normally gonna have a lot of stuff because you're handling everything in the movement. All right. Okay, so next step. So guys, remember we have. I think I'm gonna do the door first, just to make sure it works. So now we have our player running around. First, we're gonna do the walls. Actually, let's make it not go out because as you can see, this is all the camera and the player only, so it can just walk out, and you can see on the scene that it walks out and it comes back. You know, it happens. Sometimes you want that. I don't know. Or you can also make the camera follow. You know, if you make the camera follow, it's just gonna walk in the center forever or something. There's a lot of ways to do this. But no, we were doing a fixed camera, so we want to make sure the player is not leaving this area here, this this square actually. So what we're gonna do, the easier way I found doing this is I'm gonna create an empty object here that is like the walls, and reset it to the center. Oops. And then on inside it, I'm gonna create cubes. And what does that allow me to do? I can move them around. Even if you create a 3D object inside a 2D scene, it's gonna look 2D. So I'm just gonna make because it's easier to work with the size of 3D objects than with 2D. Because if I stretch this triangle, for example, and don't maintain the ratio, it's gonna be like a mess.
Yeah, it doesn't look very nice.
Yeah. So in this case, like a wall is a simple wall. I'm gonna take. You see, it has a box collider here. I'm gonna take this out, so you can check. You can click on the dots there and remove component. We're gonna have a collider in it later, but later. Now I just wanna frame this wall nicely. So this is a wall 1 or something. And I'm gonna move to the size tool. You can press R, like from Q to V. Actually Y, you have like shortcuts to these tools up there. So if you press Q, you go to the hand, and then W is moving, rotation. R is for size. And then, well, although the easier one's probably gonna be T, which is the square thing. For these basic shapes, is the easier one to find. It's normally used for UI, but in this case, it's like the easier two to use. So we're just gonna stretch this. Okay, so this is our wall. You're gonna see here. The color is the same than the, but it's over
Maybe
there.
you should change the
Yeah,
color.
I'm gonna change the color. For that, we're gonna create
Go.
a materials folder. I'm gonna put it.
Oh, wow. I mean, okay. I was
What?
gonna say maybe you don't really need to do that.
Well, it's pretty easy. I'm gonna do Rose is gonna explain more tomorrow how materials work. Probably. I don't know.
Yeah.
At least like a little bit. But now I'm just gonna create a material because these cubes are 3D objects, and this is my material. You see what I did, right? Create material here. It creates a 3D material. I'm gonna name this wall, and I'm gonna change its shader type to unlit, which means it's not affected by light, I think, and
Yeah.
color. So what? It's just a color. You see, it even like just turns this into like a 2D circle. And then to select the color, I'm gonna select like a brown or something. I don't know, like this.
That's good.
Yeah. And then I can click and drag it there. Boom, apply. So this is our wall. You see, now you can see it nicely, but as you will notice, we'll still walk through it because
There's no collider.
yeah, exactly, because it's
like
not
a-
we're not telling Unity that it's a thing you can collide with. So what we're gonna do now is work on this collision part. For that, we need to do things to the wall and to the player. So the wall is gonna have, you can to add components to objects. You can use that component here, and then you have a lot of stuff that are for different purposes. What we need is, because it's 2D, it's a physics 2D. Unity has a physics engine for 3D and a physics engine for 2D. I think it's for optimization reasons, but I don't really know. You can search more on that later if you want to. And apply a box collider 2D. But like 2D only works with 2D. I cannot mix 3D colliders with 2D colliders in the scene. I think so. Pretty sure it doesn't. Or at least they don't interact between themselves. They only will interact with other 3D or 2D with 2D. Okay, so now I have a collider here. If I put the edit, this is an edit button. You can put the collider bigger than the actual object, but by default it's gonna just surround it nicely. So you can see this green here. You probably can see it. This green here is your colliding area, and now your wall has a collider. And make sure this is trigger here is not clicked. If you click this, it's gonna be considered a trigger, which is a collider that is just checks the area, and we're gonna use this for the door plate later, the trigger that activates the door. But the wall, we need it to block the player, so it's not a trigger. It's gonna be a full on collider. So there you go. We have this collider. It's here, but the player also needs one. The player also needs a collider, so we're gonna give it an actual box collider for simplicity as well. I'm gonna move this on top here.
Unfortunately, I think Unity only has like, especially for 2D, there's only I think like circle collider and box collider.
For
I'm not
2D? Oh no. There is a lot of them. If you go on physics 2D, there's like you have a 2D capsule. Like I don't even know what these are for. Hinge.
No, but I'm saying like there's probably some that you could like edit to match the shape of your object, but it's always recommended to use the simplest collider.
Yeah. The worse your like the more complex your collider, the worse your collision is gonna. It's gonna take more. It's gonna consume more computer power to calculate the collision.
Yeah.
You do have a composite collider here, for example, and if you have like a bunch of objects together, and you apply composite to them, it's gonna make like a complex shape. But normally, even like I have a triangle here, but I'm gonna put a box collider in it because it's easier. Just that easier. And normally you're gonna use similar colliders for all the things in the game. I'm gonna use a square here, and well, it's just easy like that. And well, although these two have colliders, they're probably not gonna interact just yet because even though they are colliders, we need to tell Unity that these are physical objects, especially our player. So we're gonna add a rigid body to this guy. What a rigid body does, it tells the physics engine inside Unity that it is a physics object. So it's gonna simulate physics on it based on the engine Unity has. You can of course hard code that if you want, but I don't have the time to explain how to hard code things right now. Especially physics. So we're just gonna use a rigid body here, and
also very complicated.
Yes, yes. And I'm gonna turn this gravity scale to 0 so it doesn't fall. Because if it's this is 1, it's just gonna fall. And it's a force, so it accelerates 1 down. So we're just gonna turn this to 0 just so it doesn't fall away. You'll see it stands there, which is nice.
There's no gravity.
Exactly. And it's a dynamic. That is important. It needs to be dynamic. And yeah, I think that's all we need to do right now. Oh, and here in the constraints, there is like a constraints thing. I'm choose to freeze the rotation on the Z, because we're gonna have the boulder here later, and like if you walk into the right angle, it can rotate the sprite, and we don't want that to happen. So we freeze the rotation at all, like entirely, just so it just like stays in the position we want. So we're basically just using the physics engine for collision, and now it's not gonna go on top of this. It's not really pretty yet, but it doesn't go on top of it. And this happens, and we're gonna fix this later, because this is happening because our movement is based on the coordinates. So it puts the triangle inside on the frame I press the button and pushes it out because the collision is detected on the frame after. So it keeps doing this. We're gonna need to make the movement based on the rigid body, so the physics engine is taking care of it first. And that's where we get to that late update thing and all. But let's just finish the walls.
And that kind of, that goes into like the huge loop that I linked.
Yes.
It shows the order of what's being processed before others.
Yeah, I'll just finish this wall here, so now we have wall on the 2 sides. And then, oh, I hate this. It should be. And then this, I guess I rotate this on the 90 here. No. 90 here.
Yeah, the z-axis.
Makes sense.
The z-axis, if like we don't see it, but it's actually going like inwards.
Yeah, goes towards your face.
Yeah, exactly.
And then this is for, and then I'm gonna make the door over there. So I'm gonna make 2 here. So this is gonna be like this size, and Jesus, and this is gonna be this size as well. And then it's not gonna be like, what is it, 95, 91.
That's not a big deal.
Yeah, there you go. There you go. Just making sure. Okay, this looks fine. Yeah, it looks okay. Looks alright. Okay, so now I can play this, and we're just not gonna walk. We're just gonna be able to walk through the door here, but not out of the level anymore, which is nice. Cool, good thing. Alright, so now we don't leave the level anymore. Let's fix this collision, okay? Because then I can show how to move on rigid bodies. That's something, if you have collisions by the physics engine, you're not using like a Raycast or something. Sometimes you use that. You will want to use the rigid body velocity. If you don't want like actual acceleration force, you're gonna use the rigid body velocity. So we're gonna call this update a late update now, because we're gonna do like a late fixed update actually, because we're gonna do.
This will look at the physics first, I guess.
Yeah, it executes just before the physics, so we don't have inconsistency on the button pressing. And then instead of translating the coordinates here, we're just gonna give it so I'm gonna leave that there just so you see. So instead, we're gonna access our rigid body. So what I'm gonna do here, you can access these components inside. The components that are not by default like transform, you need to get them, and that's very important in Unity stuff. You need to find them, Because you see that I cannot just go rigid body. It's gonna show the types, but it's not gonna show the actual component to access, like the transform exists. Well, inside here actually is better. Because you can access a transform, but it cannot access a rigid body. See, but the transform exists because every object has a transform, like obligatorily, basically. But we need to find this object. To find this object, we're gonna use a thing called get component, and this is very, 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 very important to know.
And
So
useful.
yeah.
You probably, if you make a game on Unity, you
Exactly. When you
use
get a
component
component, you're
all the time.
searching this object for any component it has of the set type, which is inside these brackets here. The type is gonna be a rigid body 2D, and this is a function we call. So this returns a reference to this guy here, and then we can access all these things if you want to, or other properties that may that it has, and then you can go to the documentation, look at all the properties it has, or methods. But before doing that, I'm gonna create a private variable here to keep track of that rigid body. I'm gonna call this my rigid body, I guess. So this is gonna hold the reference, so because if we don't hold the reference, we're gonna need to call this function every time. So if we know we're gonna use this a lot, it's easier if we just get it on the start here, because it executes only once. And stay with the reference to use anywhere. If I declare outside here, I can use it anywhere in the code, no problem.
Yeah. Instead of writing get component rigid body like a dozen times in your code, you could just use my rigid body variable.
Yes, yes. So here then, now I have this rigid body anywhere. I can just call it here.
Also make sure that the object types for the variable matches the component type.
Yes, yes. Especially these physics things, because they have 2D and 3D and stuff. Make sure it's 2D, or if you want to transform, like the Visual Studio helps with that. But sometimes they have similar names to similar things. Make sure you are accessing the correct part.
What I've noticed is that for 2D games, a lot of objects you have to specify 2D, and because I think the default is like 3D games, and like for 3D you could just write rigid body, but if you're doing a game specifically for 2D, you have to add 2D everywhere. I've noticed, not just for rigid body, but like for other things like collider, like you have to write collider 2D.
Yeah.
Because
yeah, we'll see when we deal with the trigger. You're gonna see that it's like on trigger 2D, and like because it's really, really separate. So what we're gonna do is actually apply a velocity to the rigid body. It's not an acceleration, not a force. It's just velocity. It's gonna do the same thing we did here, but since it applies to the rigid body, the physics engine is gonna know how to deal with the collisions better. You're gonna see the difference. And the velocity here is a similar thing. We're gonna go right times the speed, and we don't need to apply to do delta time in this case, because it's already gonna do that. When you apply velocity to the rigid body, the physics engine is gonna apply that velocity on delta time for you. So you don't need to hard code this delta time part. I'm not sure if it uses delta time, but it does the interpolation for you. It's easier.
I'm sure that the rigid body uses like the delta time itself, because like it's trying to recreate like physical behaviors.
Yeah.
And like for example gravity, like it probably already takes into account the frames per second.
Yeah.
When it does that, so
exactly.
Probably why, because rigid body already takes it delta time
into
account.
And by doing so, this goes a lot simpler. The velocity takes a vector 2 actually, but this is gonna work. I guess we can just call this vector 2. Just make sure. Okay, because it's a rigid body 2D, the velocity calls for a vector 2 to run on the x and y axis. So you see here it's a linear velocity. So once it applies the velocity, it just goes linear, just every second, like you would expect, just like we did. It's gonna be very similar to what we did. And then so we're multiplying the right, which is value 1, on the x, times the speed again. And like that's the velocity, and it's gonna do the rest for us. See, now it's not gonna do that thing where it starts clipping.
I feel like I'm learning from this too.
But using this though, it's not checking directly the button. So what we're gonna do here is do an else, a final else, which if nothing is different from 0, so no buttons are pressed, our velocity needs to go back to 0 as well. Because otherwise, if this is not happening, you're gonna see that, what is this? It keeps popping. You're gonna see that I'm gonna press right, and it's gonna move right forever, or down, or up, or left. I need to keep pressing, otherwise it's just gonna move around forever. So just we need to reset. So if nothing else is pressed, it's gonna go inside this last else here and reset the velocity to 0. So now it should stop. Boom. And now we have our movement a lot more solid, looking a lot better. Like I said, you can use the translation, but if you use the translation in this case, and you're doing the collision by the physics, gonna do that clipping. A way to avoid that is that if you really want to code the collision with race, and there's tutorials online for that. You can do like a whole platform using Raycast. I was gonna cover Raycast. I'm not sure if we're gonna have time to talk about it. Yeah, but
I could probably talk about Raycast in the
yeah,
one tomorrow.
yeah, because to move the boulder, it was a Raycast. Well, we'll see. Worst comes to worst, I can just go by. I can just show the thing already done and
Yeah,
explain the
yeah.
code. Okay, so this is our movement here, and it resets to 0. And this is done. So I'll focus on making the door first before we go to anything else. So our door is gonna be just a thing that is gonna be up here, and it's gonna disappear once you are in that plate. So we need two things. We need the tile here that activates or deactivates the door, and the door. So the door is just like a wall, so I'm just gonna duplicate this guy here and pull it out of this walls thing. I'm gonna call this door. And then I'm gonna duplicate this material. The shortcut to duplicate is Control D. That's why I do the duplication. You can also right click and use and click on is there a duplicate here?
I don't think
No, okay,
you
so
can do Control
we can Control C, Control V.
Control C, Control V as well.
Yeah, but use Control D because it's gonna duplicate. It's the shortcut to duplicate D of duplicate, and then F2 to rename it to door. Not door. Door.
Door.
Yeah, and then the color is gonna be
Pink.
pink. Okay, so our door is gonna be very pink. There you go. And then I have this guy here. This is our door. I'm gonna put it like slightly down here. Because you see, it's still covering the same area around the camera here. So like when we see here, it's not just here. But I want this edge here just to like, this is the door. Just to give a little
no
more
explanation needed.
a little more visual cue there.
This is artistic touch. This is like level design.
Yeah, yeah. So you see now it's there. There's this thing. It's gonna catch the attention of the player because it's like pink and it's like protruding out. Just works. I can even make sure that the walls are on top of it, but let's not. Let's just leave the doors, and it makes more sense this way. Okay. So you see that it's there, and if I just hide it, it's gonna disappear. And that's what we want. This is the behavior the door is gonna have. It's gonna disappear or not. And the door has already a box collider here, which is very handy.
Yeah, it's already fine.
Yeah, so it's gonna block the player. It's already set. Player's not gonna walk there. It cannot get out anymore. So yeah, so we just want to make sure that this disappears when we want it to. And by that, I'm gonna get to that a little later. First, I'm gonna use our square here to do the plate. I'm gonna put it there.
I don't think you set the sprites. So click on square.
Did I not? I did set this.
I
Right.
don't think.
Yeah.
Oh, okay, never mind. My bad.
It does have like a little edge. So, and I call this like a activate door activator. I don't know. Door tile. I don't know. You can call it whatever you want. Door
Key.
trigger.
Call it key.
Door key. That works too. Door key.
So much trouble naming this.
Namings, yeah. And I'm gonna put this a color, any color, green or something.
Yeah, green's nice.
Okay, yeah. So you see here, there's like a green square. It's just Sprite now, so I'm gonna give it a box collider too. Now this guy is gonna be a trigger. So you see, I added a box collider 2D, and I'm gonna select it to be a trigger, cause then it's not gonna block the player. Cause if you leave it as just a normal collider, the player is not gonna be able to walk on top of it or anything. Nothing is gonna be able to walk on top of it. So what I do is call it a trigger, and a trigger doesn't block anything.
It's like an activation area.
Yeah.
As opposed to a blockade.
Yeah, and you see that when I walked on top of it, I'm up. The player gets it's appearing like on the back, like it's hiding. So we want to fix that as well. To do that, we have our renderer here has layers.
Order
So
and layer.
your order in layer is you can use the order in layer, or you can configure different layers for different things. I tend to make layers like a background or a foreground layer. In this case, they're both mainly foreground layers. So I can just change the order in layers. So I think
-1.
-1. Yeah, I can just call player 1 as well. Yeah, so let's change
Yeah.
the player 1 to 1.
Or you could do that. Yeah.
Because then it's gonna make sure that the higher the number, it renders first on the screen. So now our
Yeah.
player.
The higher the number, the closer to your face it is.
Yeah, mainly, yeah. Except that not literally, but it's gonna be rendered first, so it's now on top. That's important. Okay, so that done. We need to make sure that this guy understands that he's being walked on top of. In order to do that, we're gonna create a new script for it. Here, a new C# script. Create C# script, and it's gonna be door trigger. I guess. Create the door trigger. I'm gonna assign it now because otherwise I'm gonna forget. Click and drag there to the door key, and it's a door trigger component because it's a script. And then you open, click twice, it opens. Same thing. It has the same base here, a start update, traditional script creation process. But we don't need to set much in here. The only thing we need first is to make sure it knows that it's being walked on top of. So for that, since it has a trigger collider on it, we're gonna use a function, a method called onTrigger enter 2D. OnTrigger enter 2D.
Yeah, there's the 2D again.
Yeah, exactly. Since it's a 2D physics engine, it's 2D. Oops.
And if you have a Visual Studio with a Unity package, you just saw him. He just clicked on the method, and it just kind of auto completed for him. So when you install Visual Studio, make sure to check the Unity package, so it makes your life easier in this regard.
Yeah, yeah. And this is a method that works similar to start and update. Things that Unity calls when it has internal events that happen. In this case, when you enter that trigger. You have a lot of other trigger things. You have onTrigger exit, onTrigger stay to check if the thing is still there. Because enter is only called when you enter, literally, and not if you're staying there. So it's just called once. So let's just do this. Let's just like print here. Let's use the console for once just to show that it can do that. If you just want to see if this works, for example, you can call print. It's like a very handy little method. And then you give a string here, like walked on trigger.
Oh. My go-to is always hello.
Yeah. Like, hello, I am a trigger. Nice to meet you. You know, you can do these kinds of things. And now, you're gonna see here actually. So this is our console. So you see it has nothing. If I walk, you need to click back on the game tab if you want to like move. Because if I click here, I cannot move anymore. I'm not playing the game. I'm looking at the console tab. So I click on the game tab. You can see by the highlighter here, it highlights the tab we're active on. So the game is active. I walk on top. Boom. Hello, I'm Trigger. Nice to meet you. By the trigger here, it gives like a nice log here. So it's the time, what called it. So it's a mono behavior print method call, and it's called only once. Because I use the collapse here, if the message is repeated, like if I walk back out and on, it's calling it again, but it's not showing twice because I have the collapse set, and it just shows like a number of times it appeared. I can take that out, and you see it gives a list and updates the time as well. And the time that shows here is like the most recent one. Just a little, and that's good for debugging. Like that's super good for debugging, in general, because then you can like, oh, I'm here in this stage of the code. Okay. All right. So let's think about this for a second. Now we have a trigger that understands that the player is walking on top of it, or any kind of object, in fact. But the player is the only thing that's going to be able to in this case. But now we need to make sure that it knows that this door exists. So we need a connection between these two. And we need to make sure that once you walk on top of it, the door disappears. Okay? So how we do this, and this is like another very essential thing for Unity, is to have references to other objects. Which is like key, because it's the way you communicate. It's the way the objects communicate inside the game. So first, we're gonna make sure that the door is callable inside this door key here. So what do we need? The door doesn't need to have a script. You can do it if you want to. It may be even like better for the game if it's a little bigger. So just like things that you can link to a trigger, and you have a script for that. But in this case, since it's a simple game, I'm just gonna directly have a reference to the transform. Why? Because the transform has a reference to the object itself, and we just want to make this door disappear. To disappear, we're gonna deactivate it. Deactivating it is like clicking on this little checkbox here, so it just boom goes away, and nothing happens on it anymore. It's just like it exists, but it's not executing or anything.
It's not affecting the game.
Exactly. And so it's a very handy thing to have, because you can activate and deactivate things at will inside the game. It's not the optimal way of doing it, like especially have a lot of things.
Yeah, sometimes if you have a very like highly detailed game, maybe you want to like destroy them and make them entirely go away from the game, because if they stay there in the background, like it might take
Exactly.
computer power.
And since if you have like a very heavy physics game, 3D and stuff, you may want, like, if there is an area in the game the player is not in there yet, you can use triggers to define different areas of the game, and once you walk in that area, you activate all the objects inside, because then the physics engine, because then you don't need, it's not creating, so it's not loading everything from scratch again. It's already done, but then the physics engine is not worried about that now, because those are all deactivated objects. So you can make something like that.
Like especially for games that like have like if you're like spawning things, like if you just deactivate, they're still in existence.
Exactly.
And could continue getting cloned.
Exactly.
Yeah.
Yeah, so that's what we want to do. We want to deactivate it, because then the collider is not going to be there anymore, and then we can just walk out. Simple enough. So first, we need a reference to the transform. How do we do this? We first need to create in the code here. So this is our code for the trigger. We're gonna make sure that it has a transform reference. So this can be any transform from anyone. Okay? And it's gonna call this, we're gonna call this the door transform. Okay? Boom. Okay, so once we step on this, we're gonna call this door transform. We're gonna get its game object. which is important. I'm not sure if this works. Yeah, no. The game object, because then you're accessing the object in general, and then you have oops, uh, these functions here, the tag and the layer. You can access them by the game object, but mostly you have some methods you call, especially the set active, which is the one we want. That is equivalent to this button here, this checkbox. Okay, so set active, like I said. So you can read this tooltip here. Oops, I clicked.
Usually,
Activates or deactivates the game object depending on the given true or false value. So there is a bool here, as you can see. So I'm gonna set active. I'm gonna call this false. All right. It just deactivates the object. That's all it does, whichever is assigned here. But as you can see, it's not gonna just work because it does. The code doesn't know that it's this transform it wants, and I'm not assigning it, hard coding it anywhere here. So how does it know? It's a similar concept than the one for the speed here that we exposed it. We can expose this kind of variables. We want to attribute them from the inspector, from the hierarchy. So we have a reference to transform. We're gonna serialize this, so we're exposing it to the editor. And then once it compiles, we can go to the key here and see that it has a reference to transform here. And this can really be anything. We can even like assign a wall to it, and then once we walk there, the wall is gonna disappear. But since it's this door we want, we're just gonna click on the door here on the hierarchy, click and drag. There. So now, what happens here is that this little object here, that our trigger, has a reference to this transform here, and then you can do anything to it. You can have like, you can actually make the door move to the right or to the left instead of making it disappear. For the sake of simplicity, I'm gonna just make it disappear. But yeah, now these two are connected. This guy knows that this transform exists.
you could also use more specifically the game object instead of transform.
Yeah.
Because
That is also true. Yeah, we can also name this game object instead. Door. And
there's
then
no difference.
yeah, and then you would just do this. It's also something that works.
Also, you should delete your print. So
Yeah, it's not gonna.
just because when you're making games with other people, sometimes people forget to delete their debugs, and when you're
and then
trying to
there's a
fix
lot of
errors in the console, there's like some random things.
yeah. That's
So-
important, or at least comment them out. It's
Yeah.
yeah. Okay, so similarly, if you change, like I saw, I just changed this. It's now a different kind of variable. It recompiles, so it loses the reference. You need to click and drag again. Boom. So it has a reference to this entire game object here that is the door. In this case, since we're deactivating it, we want the game object entirely. But normally, you're gonna have a more specific thing here, for the sake of safety as well. Like either the transform, or you can access directly a script, and like just call certain behaviors you scripted it to have. So yeah, you can define it. If it's not like a primitive, which is like a float and int, and it's like a component or a game object, you can serialize it to click and drag here. You can even assign other things, but yeah, mostly to connect things on the scene. This is the way to do it. Okay, so now you're gonna see that I'm gonna walk. I think it should work, and then it disappears.
Woo.
And then I can walk out. Nothing is gonna happen because there's nothing there, but you can get out of the room, and the door doesn't come back. What we can do now to make sure that you need like the boulder for to do it, and we can like make it later, is to use the exit. The exit is called once when an object exits the collider. In the same way, we're gonna do set active to true here. True. And then you're gonna see that if we walk with the player there, it's gonna disappear, but then if I walk out, the door is back. So you would need to have something in there. Okay, I'm not sure if probably not gonna have time to do the boulder. I'm gonna explain it to you later, but for now I'm just gonna comment this out just so we can play. I'm gonna show how to do the exit and scene transition, and then that's probably gonna be all for today. That I'm gonna actually show live. Okay, so we want to finally um, exit the level, finish the level, or finish the game. You want to do that. In order to do so, we're gonna do a nice empty object here. You can just like right click and create empty, like this, or game object to create empty work, or Ctrl Shift N. There's a lot of them, and we're gonna call this exit. And then we're gonna give it a box collider 2D. That is gonna be a trigger, because you need to make sure that it knows when it's being walked on top of. Every time you need to like these kinds of things that you need to know that it's being walked on top of or passing by or something. You can use triggers for that. It's very handy. And I'm gonna put this trigger here. I know, just make it a little bigger. Make sure the player can already exit the level, even like extrapolate a little. It doesn't give any edge to walking out. And I'm gonna put it a little inside here, just make sure the player doesn't really walk out of view before the scene actually changes. Okay, so now this is our trigger there, exit trigger. I'm gonna even like hold. I can hide the door here, just to like, so this is very visible. You can do this actually. No. Yeah. So the trigger is there. Now we need to make sure that it exits the level. First, I'm gonna create a scene, like a good job scene, like I did on the game. So it's a create scene here. I'm gonna like end scene or something, and I'm gonna load this. You can click twice. It's you're gonna ask you if you wanna save the scene. Save the scene.
Always say yes.
Yeah. And change the scene. There you go. So this is our new scene. It's a default scene. It has a camera and all that good stuff. It even resets the color, which sucks. I'm gonna make this black because it's just gonna have some text there. So I'm gonna show some basic UI here. So any UI you have when you're going to like right click or you go to game object, you have UI, and then you have a lot of things. So like you have text. You can, if you want to show like some text. Like an image, a button, and the UI is not a sprite. Any UI element, they're not sprites. They're considered UI elements. So as you can see, I'm gonna create a text, and it's gonna create a canvas for me. And you see the canvas
is always
this big thing, like big
needed.
huge thing. So you see, this is the canvas, and the camera is there. This little tiny square here is our camera. So this is actually the game, and this is our canvas. Where the UI happens. You even see the text here, over there. I can move it here. Because what happens is, it does this just for visualization, because then you can really get out of the scene and look at your UI very fast. And then you notice that in the game, it overlaps your canvas UI with the camera. And it's actually a configuration you have on the canvas here. It is an overlay. You have other like other options, but normally like for menus and stuff, you're gonna use overlay canvas because then it's just gonna be drawn on top of your camera and on top of everything. Any sprites you have, anything, it's just gonna be drawn there because it's UI. The UI normally like is the thing that's like most to the player, closer to the player. Okay, so let's just mess with the text a bit. The text has a lot of things. This is the actual text that's being displayed. I'm gonna change this to good job. And I'm gonna change this color to white since the background is black. So now you can see this better. And then you have like normal font configuration. You can change the font, you can change the size, the style. As I can make this bold and really big. Oh, so you can see I
Maybe a
made it
little too
big.
big.
Yeah. The size, like if you go over the actual square for the text here, let me see, like here, there. So you have this area here. This is the display area. So if your text gets bigger, it's gonna disappear. So I'm gonna make this bigger to make sure that the font fits. Okay. And then I also am gonna mess with the alignment here. Make sure it's centered because it's easier to position that way. And then I'm gonna position it here, and boom. See, it just shows up there. Good job. And now I'm gonna go and do a button to restart the game, just like later. First, let me there. Let me return to our game, and I'm gonna make sure that these trigger there. Where is the trigger? It didn't save. Oh, it's here.
I was just.
And I was like, oh god, no. Okay, it's saved. So our trigger here loads this scene. Make sure the scenes are loaded, and this is very important. You go to File, Build Settings. So this build settings is what you're gonna configure to actually build the game and make an executable, so you can like share it with your friends or upload somewhere. I'm gonna do a build later, but first we need to add scenes to this, and like it's just a click and drag again. So you have our scenes folder here. Our test is our first scene. You add it first, so it's 0 on the index, and then our end scene is the next one. Okay, so these indexes here are important. You call them either by name. You can call them like tests, or you can call them by the index here. I'm gonna show it in code how you call the scene, because then when you load a new scene, the scene you are currently in is unloaded and like thrown away, and the new scene is loaded and shown on the screen. And the first one here is the first scene that is loaded. So if you had like a main menu, it would put it first, and then like go from there. Okay, so since these guys are in the build settings, now there is a thing inside Unity that is a scene manager, and it knows now that these two scenes are gonna be built, so they can be loaded. Because you can have scenes here that are just test scenes that are just testing your code, and not like final game stuff. And those you don't add to the build settings because you don't want them to be there. In this case, our test here is gonna be our main game. I'm gonna even rename this to main.
If you have teammates, make test scenes.
Yeah, always. Good practice, especially in game jams or like, because you're doing things so fast, like you're making a new feature, make a separate scene and work on that scene, because otherwise, for example, a Git, if you're using source control, cannot really keep track of the details of the scene. It doesn't know how to, because those are Unity specific extensions. So if you do like something on the scene that others are working on, whichever is the newest version of the scene is gonna be the one that Git has. So like if you do like a lot of changes that are a lot different than the changes someone else did, it's gonna be like whoever has the most recent timestamp is gonna be the one that Git has, and you may lose your scene, or the other person is gonna lose their scene, and it's gonna be a mess. So always make a separate scene for things. Always. So as you can see, it updates the name there to main. Okay, so we have everything there. Let's go to actually changing the scene. For that I need a new script again, because this script is gonna be here. I'm gonna create a script directly here. You can add component, new script. I'm gonna call this exit level. Create and add. You can press enter as well, and it's gonna create them for you. It creates in the assets here, as you can see. That's why I normally create it directly in the scripts folder and assign. It's a little easier, because then it's already there. But now it's created exit level. I open it. Okay, and then same thing. It always creates with these default two things, but we don't need this here. Similar to the tile there, to the trigger for the door. It's trigger. So we just entering it, and when we enter it, we want to change the scene here. So change scene. So what we're gonna do? First, we need to do a using here. Using is like an import. If you've coded anything before, you have like importing Java, or you have include in C. In C# is using basically, and then you're gonna use the Unity engine dot scene management. So what does this allow us to do? This allows this script to use the scene manager, which is the thing that controls the scenes in the game, and then you just call the scene manager like this because it's a script, and then you can load scene. Load scene is the thing you call that is gonna load a new scene. When you load a new scene, it changes the scene for the player. It's gonna change the screen. So we're gonna load scene, and we're gonna load scene 1 because on the build index here, just let it load. On the build index here, and scene is 1. What we could also do is get the current scene, get active scene, build index.
This is a lot more complicated.
Yes,
than
because
just
but
one.
this is easier normally because like if you have a game that is like maybe procedurally generated or something, or you have a lot of scenes and you just like go into the next scene, you just get the current scene plus 1, and then it doesn't matter if you like you can just rearrange the scenes here. Don't need to hard code anything.
Yeah.
You're just gonna be like, oh, so I'm on scene 0, load 1.
But in this case, the order would matter.
Yeah. Yeah. Like if you're calling the index directly, the order matters. But if you're calling the names, the order don't matter. So it's you can also call like directly here, like what's the
The
name
name.
again? Terrible end scene.
And scene.
This also works. But I tend to do this just because I like the organization.
This one has more flexibility.
Yeah, yeah. But it's a case by case situation. Okay, so this should work. Let's see. Since I created, I don't need to apply it to the door because I created it. So we're gonna walk here. The door disappeared. I'm gonna walk out. Boom. It changes the scene. Good job. And okay, so that's like how you exit the level. I'm just gonna make sure to show you guys one last thing then, which is a button here. When you have a main menu, you're gonna have like a start game and stuff. So a button is something you create a UI button, similar to the way you create a text, and it even creates for you like this like framework and stuff. It's a default Unity button. Normally, you won't have time to personalize this because you can see it here. You can do like you can have like a nice frame and like standardize your UI with like art style and stuff, but that's not something you're gonna have time to do. So
Yeah.
yeah,
The default button is fine,
yeah,
in my opinion.
yeah, exactly. So I'm just like giving the button a little more size here, and then I'm gonna go to the text inside the button. So you see the button is actually this white area on top, and the text is inside it because it has a text button. And so we're gonna just call this replay or start over. I don't know. Restart. That's what I want. Restart. And the text already centralized. I'm just gonna make it bigger. I'm gonna leave it black because the background is white. So you can change to the game scene and already see. Okay, so this is ready. The aesthetic of it, and then when you have a button, you have this here. This is the actual button stuff. You can even change like some details of it. Like the color can change when you're highlighting it, like when your mouse is hovering, or when you actually press or select. The color can change. I can even show you here. So the normal color is white. And then I'm gonna make this red, I don't know, yellow when you hover. Like this very pale yellow. And I play the scene. It changes. So I'm hovering on top of the button. And then I can even go a step ahead, and the select color can be a green.
I didn't know you could do that.
It's very handy because then you hover. So I'm hovering this button, and then I click, it becomes green. And then it executes the behavior you want it to. Then whatever happens on click is what happens in here. And you can have even like more than one event, I think. But normally you have only one because this button is just gonna do one thing. So you click this plus here, you're adding an event on click. And then you need a reference to an object in the scene that is gonna execute whatever you want it to. I'm gonna make just like an empty object here that is gonna have our script. And this is like a button controller or something. And then I'm gonna make a script for this guy. I'm gonna call it restart game. Just very, very fast. And it didn't open automatically. I don't know why. I'm gonna put the restart there and open it. It's the same thing, but in this case, we just wanted to have a method that you can call on click. So we were gonna do a public method. Okay, so methods you want other scripts, even if you have a reference to that script. If you have private methods inside a script, and like other script has a reference to it, you cannot call private methods. You can only call public methods. In this case, it's just like what's happening. We have a button that has an on-click event that is gonna call a method inside a script. So that method needs to be public, always public, because then it will give it permission to be called by any other external means. And like the actual restart method, which we're gonna call it restart. It's a void restart. Needs to be public because of that, because it needs to be called outside of the script. We're gonna use the scene manager again because it's what handles those, and we're gonna load the first scene. So scene manager, load scene. I'm gonna call this 0 because it's the first scene. In that case, like if you have a main menu or something, it's gonna call the main menu. Or you wanna go directly to the game and you have just, you can load any scene here. It's just gonna work. So so you see this on click here. I added the event. I'm gonna click and drag the button controller there. So now it has a reference to button controller, and then the function it's gonna call, it's gonna be a restart game script, restart, because I defined it here. Restart game, restart, which is gonna load the game scene again.
That's why it had to be public, because it wouldn't be able to see. If it weren't public, it wouldn't be able to see.
Yeah. If I create like a private method here, private void secret restart, haha, or something, and I don't know, and I print, you can't use this dummy, and you'll see it's private, so when it compiles here, it's not even going to show. It's not here anywhere. But if I change this to public, it's gonna recompile and then it's gonna show here. Secret restart, haha, see? And I can even call it and like make the button print. You can use this dummy in the console. So yeah, it needs to be public.
Make sure to put the right one.
Yeah. There. Okay, so the restart is set. So what it's gonna do, when I click restart, it's gonna load the game scene again, and then we have a nice loop. So we hover, click, boom, restarts the game. I play it, deactivate the door, walk out, here again. There you go. And then you can like use this knowledge to like make a main menu, and then the main menu starts the game, or you can load a specific level. You can have a lot of levels, things like that. Yeah, and then yeah, that's it. I think that's all I can cover. I don't have any more time. It's already 7.
Yeah, well, I mean, we don't really have a time limit for this.
Okay. Then I'm gonna show the boulder, but I'm not
just
gonna
like show like tags, I guess. And,
I didn't have any tags. No,
I don't know how you use the boulder.
No, the boulder was a Raycast actually.
Oh, okay.
Yeah. I'll use the enum to have a direction, and then I will Raycast to the side, and make it like. I'm gonna show because then it's in the video and people can rewatch to understand.
Yeah, that's fine.
Yeah. Any questions so far? By the way, I just closed the project, which is sad. From people watching. Oh, there's a lot of chat there. I'm sorry.
No. You didn't miss anything. I think you're.
I submitted your game to IGN and they rated it 10 on 10.
I'm pretty sure. Oh, did you see the one in the beginning? The one is that I made.
I just put up now.
Oh, it's even more amazing. I'm gonna show it to you. I'm just gonna load the other project. The code is gonna be a little different because I just did it like from yesterday to today. It's gonna look a lot more like game jam code, I think. You see, it's a little different. It has the walls in different color and stuff. And like this is my default UI for the editor. Don't mind that. But it works a similar way. You're gonna see everything we did. You can walk to the tile. It's gonna get the door out and back, and so you cannot walk out. The only difference here is that you can push this guy around, which would be, or you would be able to, but then I just messed it up.
You gotta make
Oh
sure.
god. But then that's why I have a space button.
You failed the game.
God, there is
The
a way to
simplest
lose. You
game.
can get stuck. There. You
you
push
can
it.
make the hitbox a triangle, no?
Yeah, it's also possible, yeah. But I
Yeah.
just made it like square, just for fun.
Did you use a rigid body, or is it moving it a different way?
It's a rigid
It's
body.
using rigid body.
Yeah, because we're colliding with the sides here. I had to turn it to the rigid body movement.
Cool.
Yeah. I explained the translation first though in the beginning. Yeah, so I'm just gonna put open up the code here for the boulder. So as you can see, I'm gonna stop playing. The boulder is an object that is very similar to the player. It has a layer. It's called movable. These layers here. This is very important. When you have collisions and collisions
Well, wait,
and like
when you're using Raycast, especially.
yeah, especially raycasts, you use one of two things: collisions and raycasts. When you're having collisions, especially triggers, and you want to make sure that that one thing activates the trigger, you use a tag, and a tag is something you can see here. For example, the player has a player tag. I can actually show this. So you see that the player activates and the boulder activates the tile there. But because my trigger doesn't check, oh, it's gonna open up Visual Studio again. Yeah, so the trigger just activates whenever anything goes on top of it, and in this case it's fine. But normally you want to just make sure. So if I check, so you see that it gets another here. This guy is the thing that entered there. So this is the other collider. So you check the other collider for its own game object, I guess, and then you check the tag, because then so you can see the path here is the game object, which is this entire thing, and then you check the tag. You can check the name as well, but I don't. It's really not optimal. You can use tags for that. So check the tag to be equal to the.
Sometimes there'll be like a bunch of objects that have like the same name.
Yeah.
So
And then I put this
tags
inside.
like it's better to categorize different objects in the hierarchy.
Yeah. So if I check this before, it's only gonna deactivate the door if the player walks on top of it and not the boulder. And then I just broke my game because there's no way to go out. But you'll see that I'm gonna go with the boulder there. You see that it doesn't activate, but if I put a triangle, it activates and deactivates. So I'm checking the tag here. That's a way to like make sure things don't interact with things that you don't want them to. When you have more elements in the game, you really want that to happen. Like an enemy doesn't damage another enemy, it damages only the player. Those are things you really want to check. Yeah, but I'm gonna remove this because I want the boulder to work.
Tags are very useful.
Yeah, and I left that the player can actually walk on and deactivate the door just to make like, because the first thing you would do in a game like this is really like walk either way. So if you happen to walk to the tile, you'll see the door disappearing, and you're gonna be like, wow, the door opens, and then you walk out and it's closed. It's like, oh, it feels sad. It's all about the game feel, guys. All about the game feel.
You took some time doing that game design.
Yes. I had a lot of planning,
Trying
like
to recreate the player's experience
yes,
in your head.
exactly. So yeah, but the boulder, which is important here, two things. The player does something different. For if I play this game, you can see that there is this little line here. Let me deactivate the camera again. So this little line, this little cute line red in here, you can see. I'm gonna zoom it out. So this guy.
That's very zoomed.
Yeah. And just to make sure, you can even see here is a raycast. What is a raycast? A raycast is literally a ray you shoot inside the game from a point to another point. So what did I do? I used that kind of knowledge, and a raycast hits something, and that's where the layer mask comes in. The boulder, this guy has a movable. Is on the movable layer because I wanted to prototype this in a way that I could make other things movable inside the game. It was just more like me future thinking the code more than actually just thinking about the value to teach this. But yeah, you have layers, and when you define those, you can use those for raycast detection, and you can have like 31 layers of things. Well, 31 minus 7, I guess. And like it disappeared. And then I defined a movable one. This one's I typed, so it's a movable layer. So the code here is a little different than when you saw, but there's some similarities. I made a speed here that you can change in the Spectre. I made
Oh, this is a lot.
I made a handle input. This guy is what handles the movement here. It does like a similar thing.
Oh
But-
yeah, that we already covered.
Yes, we did this like a little simpler. What I did different here is that I defined this thing because I wanted the ray to shoot to the way to the direction the player was facing. So I need to keep control of the direction. And this is very handy. And using a nums for this, you can ignore this other one. I was just messing around at this point, but direction is very key to the behavior here. Is that once you press a button to a side, and you can see this in here actually, like I did, you check if they are 0. I did a little different, check if they are 0 first instead of checking of doing the else here, because I wanted to keep the state to moving. And this having states like this helps you have control. For example, if you have animations. So in this case here, I would know that the player is moving, so I could have an animation, like, and then I could play animation here. Play animation of like moving, or when it stops here, you can like play idle animation. It's very useful to have these kinds of control if you want to. And then once I move, like for example, this is right. I get the input here first instead of checking it every time. I get the input here. I put it on this variable. I check if it's to the right. If it's to the right, the movement's gonna be to the right. I assigned the speed directly here instead of using the vector right, vector up, because I forgot about them when I was doing this code. But yeah, so you see that I defined the direction here to be right. And then, okay, so this defines that I am facing right. When I press right, I'm facing right, correct? That's what it should be. So when I get to this code, so you see the update loops a lot. I loops every time. So I handle the input first, and then I shoot the ray every frame. The ray is just literally ray. You don't need to really get the very intrinsic details of this, but you have an origin point inside the world. You have a direction it goes to, and it has like a distance it covers that is defined here on top here, and it's serialized, so I could debug it as well for better feel. So yeah, when I get to this part of the code, I check the direction the player is looking at, and then I use the up, down, left, or right to define the direction of the ray, and not the movement. Don't ask me. I had so little time to plan this. This code could be a lot better.
That's fine.
Yeah.
Is ray direction what variable is ray direction?
It's over here. It's a vector 2.
Okay.
Yeah, it's a vector 2 ray direction, because when you're doing a raycast on physics 2D, this is important. Again, the 2D appearing. If you are using a 2D game, you do everything 2D, including your raycast. So the raycast is a function you call for physics 2D, and it's called raycast because you're literally shooting a ray. And then, as you can see here, it has an origin.
The initial point, basically.
Yeah, which is where it goes from, and that's where I get the origin of which is the transform position. I think I defined it here. Yes, but because it's a vector 2, I had to get the position x and y separately, because the transform is a vector 3. The transform position is a vector 3, not a 2. So I converted it to a vector 2 with x and y. That's our origin here. And then the direction, it depends on the direction I'm facing. So if I press right, I'm looking right, so our direction is vector right. And I did 2 here because the debug ray is only 3D and not 2D, so that's why there are 2. But the actual ray I'm casting goes to the right on vector 2, so it's 1, 0 vector. The distance is something that I can change in inspector just so I can just so I had control of how far the ray goes to, and this is in I think this is a float. Yeah, it's a float, a ray distance float. And then it checks the mask. This is where the mask comes along. It only hits, so the ray, you shoot the ray, it's only gonna hit if it's a movable, it's in the
Layer.
movable layer mask. Exactly.
Yeah.
So only thing in the map that has that is the boulder. It's the only thing. If it hits the boulder, it's gonna hit here. So you have a result, which is a raycast hit object, and then you can read I don't really can go through this in detail right now, but it's basically what stores the result of your ray, if it shot something or not in that frame. And if it hits something, this transform, because it has a reference to the transformer, it has a collider, a reference to collider and a transform or other things, but mainly you're gonna use either the collider or the transform of the object to hit. So if you hit the boulder, for example, this transform is gonna be the transform of the boulder. And if it's not null, so it means it hits something. So I print hit something. I was debugging this, and then I get the component that is the script inside the boulder, which is a movable object. I can open it to show you here very fast. And then the movable object is this script here, and I call push. I define the public method here called push. What push does? It sets the boulder to be moving. It's a boolean here. It's just a boolean. It's just true or false. It sets the direction. It's the same kind of enum that has in player controller. That's why there is this reference here, because I need to know the side it's gonna walk towards.
Yeah.
So I pass the direction. That's why the direction's here. I pass in the direction, and I'm passing the speed I am currently on, because I want it to be pushing the same speed the player is moving. Since it's something it's not hard coded, it's changing. I'm changing every time to in the specter here. It's something I serialize. I pass that on to here just to make sure both are synchronized. So I call this. I give it the parameters it needs, and I call the handle movement, which is exactly the same movement we did for the player. It changes the velocity of the rigid body to the translation, so to the speed times the vector here. I could do like right times speed. Again, I did this before. Well, actually,
this is exactly the same thing, basically.
Yeah, but
I mean, almost the same thing as we did for player, except you're applying it to a boulder, and you're applying the variables from.
Yeah, the thing is that instead of using like, actually, I should comment these guys. This is what's wrong. Yeah, there you go. I didn't remove these because I'm not translating anymore. So what I do here, instead of translation, I'm gonna call this like direction vector, I guess, just and this happens a lot. You're gonna change names as things go. Just to be clear, it's good to give clear names. Translation was a good name before because I was doing the translation, but not in this case. So similar to what we did in during the recreation of this, I set, but instead of using like vector right times the speed here, I just set the speed directly and I create a new vector 3 with the speed directly. It's the same thing. Instead of using like vector 3 dot right times speed, because it's literally the same thing. Because when you're multiplying a number to a vector, you go like unit by unit of the vector. So it's since right is just 1, 0, 0, it happens to be this guy. And the same thing for, I just multiply -1 here because speed is just it's not a number that changes to negative if you're going to the other side. Anyways, and then that's it. But then it starts moving in the direction that you are moving, like there you're pushing it.
So basically, to recap, if you go back to player controller, you use Raycast, which is on the player to check the direction the character is moving. So
Yes.
that's the enum.
I can actually show this here
right,
better
left,
because I
right,
draw.
top, down.
Yeah, so I press right
And then
I press left to see that the ray mirrors to the other side, or top, same thing, or down.
yeah. And then you also check. You use the Raycast to check if the line that you did that has a certain distance.
Yes.
Touches are movable layered object
Which is this boulder here.
with the boulder, and if it does, which was the variable result in the code, if it does hit it, the boulder will move in the same direction and speed as the player object.
Yes.
That's it.
Yes. And that's what it does. It just pushes. And then like I just fucked this up again. If you push to the side, you cannot like I didn't put like
you can lose at this game. Which is
yeah.
funny.
I didn't make a thing to like you can drag it back. So I made the space button just reset the level. just for the sake of this. So yeah, that's what it does. I'm pretty sure that's the Raycast working here because I put the rigid body later. I'm not sure if it's pushing, but I don't think it is. Oh, and this is a bug actually, because since the player can deactivate the like I can walk in and out and activates and deactivates, right? So if I
Yeah.
push the boulder inside, but I walk with it, like here, and then I walk out, it's gonna close it.
It like slides away.
Yeah,
It looks-
both slides away and also closes the door. But like, there's a way that I'm gonna really put this very slightly. Okay, here, and then I walk.
And that's yeah.
Here and I walk out. It closes.
yeah.
And then I
It's
cannot do
because-
anything about this.
Yeah.
I need to push it
So
back.
that's part of debugging and fixing code, which is a whole other like process.
Yeah, yeah, yeah. I
which
didn't
we
have time
probably
too
don't
much.
have time
Yeah.
to do today.
just to go like around. The boulder has a rigid body because I'm applying velocity to it, similar to the player, and I didn't want it to clip with the walls like it happened with the player before. I freeze the rotation, same thing, same configuration, and also box collider. It's just the same configuration here, and also it needs to be dynamic here because it needs to collide with the trigger. Otherwise, it's not gonna do that. So it could be a whole lecture on the colliders and how different colliders interact with each other. But
Yeah.
I'm not gonna get into that. Just know that it should be that way, in this case. Yeah, and that's.
Does anyone have any questions?
Yeah, I know this last part was a lot.
Like yeah,
you
we
can ask
kind of,
questions
like,
now or
rushed
ask
through it.
questions to me later. There's like I can give whole videos on Raycast because it's like a thing that is very widely done. A thing that I could do better, for example, in this case, is not only Raycast to the side like this. I could Raycast from the middle to the side and then also from the top and from the bottom, because if I play this and I get out of range of the collider and I just walk. Oh no, this is working. Oh, because the rigid body then. This sucks. But if it didn't have a rigid body, only the ray detection, it would walk on top of the ball, because the ray literally hits only in this point. So normally you'll have like at least 2 or 3 rays to make sure you cover the entire length of the sprite. So I would put one here like this, one here, and one here.
Yeah, one at the bottom, one at the top.
Yeah. But yeah, I didn't want to make the code bigger than it was because I thought I wouldn't have time to code it
Yeah.
for you guys, but that's fine. Yeah. Was that too fast? I mean, I know it's like 7:20, but like this whole entire finish like end part was 20 minutes.
Yeah, it's fine. It's good that you covered it, and if people want to look at the code more closely, I think they can. Maybe you could like provide it to them.
Oh yeah, that's true. That's right.
And,
You can
people
cast
could
other
recreate
things.
it and kind of go through it themselves as well.
Yeah. Yeah.
So yeah, I
Yeah.
think you should do that.
Yeah. I'll upload the code and then give the link here later. Then I'll just pack it. I'll just do up. Just zip the entire folder and put it on Google Drive, and then I can put it on the with the video on YouTube, and also post here. Do both of them.
Yeah.
Yeah.
Perfect. All right.
Yeah,
Well,
that's all. No questions then? Yeah, that's what I said on YouTube as well. It can be questions from like the things before, any doubts, any feedback. Was this too overwhelming for people that are new?
I think it was good.
Yeah, I didn't go into like complex ground. I didn't want to. Yeah.
All right.
Yeah,
Well,
okay.
it looks like there's no questions, so
Yeah, okay.
I guess we'll conclude this.
Yes, I'll finish this. I'll finish
So-
recording this right now. So
Thank you,
yeah.
guys, for watching.
Yes.
And, so me and Tiffany are gonna do just a little overview of like smaller tools that